Alrighty, last but not least, problem 1.62. On a training flight, a student pilot flies from Lincoln, Nebraska to Clarinda, Iowa, next to St. Joseph, Missouri, and then to Manhattan, Kansas. The directions are shown relative to north. 0 degrees is north, 90 degrees is east, 180 degrees is south, and 270 degrees is west. Use the method of components to find the distance she has to fly from Manhattan to get back to Lincoln, the direction relative to north she must fly to get there, and illustrate your solutions with a vector diagram. Okie dokie. So to answer our first question, the distance she has to fly from Manhattan to get back to Lincoln. So essentially what we're doing here is we're taking the vector sum of these. So we're going from Manhattan to Lincoln. So first we need to figure out how to write all of these in vector notation. So the directions are shown relative to north. So that means this is 85 degrees from north. This is 167 degrees from north. This is 235 degrees from north. So when we report our final answer, we want to report it from north. Okay. So let's break these up. So Lincoln to Clarinda is 147 kilometers at an angle of 85 degrees. So our x component is going to be opposite of 85 degrees. So let's call this, we'll call this vector 1. Vector 1. That's a vector hat sign. That's hideous. Let me try that again. Vector 1. There we go. Okay, so we're going 147 kilometers at an angle of 85 degrees. So our x component is sine 85. And that's to the right, so that's I hat, positive. Okay, so then our y component is going to be our 147 kilometers adjacent to 85 degrees. So that's going to be cosine 85 j hat. Okay, actually no, we're going to leave them in. We're going to leave them like that for right now. Okay, vector 2 so this is 167 degrees with a magnitude of 106 kilometers. Personally, I don't like dealing with angles greater than 90. So I'm going to recognize that this angle is going to be 180 minus 167. So that's going to be 13 degrees. Just double check that I know how to do basic math right now because the last couple videos have shown no. Yeah, so 13 degrees. Okay, so now our x component, we're going to call you vector 2, is going to be 106 kilometers. And my x component is, again, because I'm choosing to use 13 degrees, that's going to be opposite. So that's going to be sine 13 degrees I hat. And then cosine 13 is going to be my j hat. But I'm going downwards, so that's going to be negative. I'm going right, so that one's positive. Okay, so just for clarification, that's step 1. This is step 2. Now let's look at vector 3. Let's make you green. Okay, so now vector 3 is going like this whole angle is 235 degrees. I don't like dealing with angles greater than 90, so I'm going to figure out what this one is. So 3/4 of a circle is 270 degrees. So 270 degrees minus 235 tells me that this angle over here is 35 degrees. So my third vector, this one has a magnitude of 166 kilometers. So it's going to be 166 kilometers. My x component is adjacent to 35 degrees, so that's going to be cosine of 35 degrees. That's pointing left, so that's going to be negative. Similarly, we have 106 kilometers. My y component is opposite, so that's sine. And it's pointing down, so that's negative. Okay. And so we have blank space, so we're just going to scroll down. So now, what we're going to do is if we take vector 1 plus 2 plus 3, that tells us how we got from Lincoln to Manhattan. So where did we start to where did we end? So let's say from Lincoln to Manhattan is 1 plus 2 plus 3. Okay, so if we do that, we can take our x components. So that's going to be our 147 sine of 85 plus 106 sine of 13 minus 166 cosine of 35. Oh, and I just realized that should be an I, not a J. My bad. Okay, so if we punch that into our handy dandy calculator, that comes out to 34.3 kilometers I hat. So now we can go through and do the same thing for our j hats. So 147 cosine of 85 minus 106 cosine of 13 minus 166 sine of 35. For negative 185.7 kilometers j hat. So that's getting from Lincoln to Manhattan. So if we want to go from Manhattan to Lincoln, all we have to do is flip all the signs. So from Manhattan to Lincoln, Manhattan to Lincoln is the negative of 1 plus 2 plus 3. So that's going to be negative 34.3 kilometers I hat plus 185.7 kilometers j hat. So now we're going, let me just erase all my scribbles on here. So we're to go from Manhattan to Lincoln, we're going up. So that gives us our plus j hat. And we're going slightly to the left, which gives us our negative I hat. Okay, so those are our vector, that's a vector components. So now we want to find the distance. So that's going to be the magnitude of that vector. And the direction relative to north she must fly to get there. So now that we have the vector components, that's our y component is 185.7 kilometers. Our x component is 34.3 kilometers. And it's negative, so it's pointing left. Bam, bam. So to find the full length of that vector, we can just do Pythagorean theorem. So the magnitude of, we'll say, answer is square root of negative 34.3 kilometers squared plus 185.7 kilometers squared. So you can punch that into the handy dandy calculator. 4.3 squared plus 185.7 squared gives us 188.8 kilometers, which if we're going sig figs should be 189. Yes. Okay. So that's the magnitude. So that's how far she has to fly to get home. So now I want to find the angle. So given this triangle that we've measured here, she wants it measured from north, so from the vertical. So again, I don't like dealing with things over 90. So it's a lot easier to find this angle and then subtract it from 360 to get this angle, which is what they're looking for. So let's find this angle here. So this angle here, let's use tangent because I like tangent for some unknown reason. So we're going to do our angle is the inverse tangent. Tangent is opposite over adjacent. So typically when I do this, I ignore the signs and I add the signs in later because your calculator can't tell the difference between quadrant 3 and quadrant 1. So if we do it without signs, that tells me that that angle is 10.46. So we'll round to 10.5 degrees. So that's this little angle here. So if you were to punch it in with a negative 34.3 over 185.7, you would get negative 10.5 degrees. So that's essentially what it's telling us here. Because we're measuring from y, the standard is to the right. So getting a negative answer just tells us that we're going to the left. So we can either report our angle as negative 10.5 degrees or 360 minus 10.5, which is 349.5. So both of these angles tell us the same thing. Just one's pretty and one's not. I don't like angles over 90. That's just me. Okay. Is that the end of the question? Yes. And we illustrated with a vector diagram. So GG team, I'll see you later.